Good afternoon. I know that you don't like me, you hate me now, because it's a break time, an afternoon. But bear with me, because AI is important. And I'll take you through something maybe very advanced, but I try to simplify it in a way that everybody can understand it. So this is the title, Rethinking Education Teaching with AI, not against it. So we go with AI, but not against it, okay? And this is me, Tarik Rashid. I'm a Principal Fellow of Higher Education UK, graduated from Ireland, University College Dublin. I did my master's, my PhD, my postdoc, and I'm a professor at University College Dublin and director of Center of AI. Details about me can be seen or viewed there if you have a chance to get there. So I have 30 minutes compact, and I'll try to make it shorter because we are starving for lunch. I'll take you through the definition of AI first, and then I take you through the history of AI, which is very, very important. And also, I'll go through the main topic for today, rethinking, how we change ourselves so that we can adapt to today's AI. And then I hit on the main points of today's presentation. Now, definition of AI, it's a machine that you put program on it, okay? A machine, just a program on it, it becomes AI. And we are trying to create a machine whereby mimics human intelligence. When we say intelligence, means that we relate it to human. Okay, human is intelligent. And we can mimic human behavior, thinking, and action as well. Okay? So that's the basic definition. AI has some foundations, components. One of the components called computer science. Computer science programming to tell the computer how to do the work, the instructions. And the second, data structure, the way to organize your data so that you can retrieve it, so that you can have it, update it, edit it. And then algorithms, which will be the future, future advanced things, that algorithm can do great things in our life. And then software development, the developing of software from the gathering information, coding, testing, maintenance, until you provide the software. And then the second component, it will be mathematics. And mathematics, something that we do and we don't like. Statistics is part of the mathematics. It's about the history of frequencies or events that we analyze so that to predict. And then probability, of course, AI has to have statistics and probabilities, future event prediction. Then calculus, this one, differentiation and derivative, and vectors, matrices. Then linear algebra equations, linear equation, y equal mx plus b, things like that. And then the third part, which comes to big data. Big data means that you have sets of databases or sets of data sets. Collecting them, organizing them, working with them, processing them, normalizing them, scaling them, denoising them, and then analyzing this data, which is very, very important. This is the fuel for AI. Fuel for AI, these are the fuels for AI, the data. Okay, without data, AI cannot do a job. And then managing all these things. And now, this man, Alan Turing, he has two theories. One called Turing machines, okay, the one that started to break the cipher, the German cipher, the German code in the World War II, and had impact to the victory of Allies against Axis. And then the second machine that he has was Turing test, whether machine can behave, can think like human. He had a tragic story, like Alan Turing was prosecuted for being homosexual. And back then in UK, homosexual was forbidden. He was jailed, and he died because of, taking a lot of poisons, but believed to have been suicide in the UK. In 2009, UK government apologized for his contribution formally. In 2013, that was, a true apologies from the UK government for Alan Turing. I mean, Alan Turing made the first foundation of AI. Then comes with the first early AI program for proving mathematical models. And then ELIZA was the first chatbot. The first chatbot was 1964 for helping psychotherapists with the patients. Then in 1960, the first robot came up, Shaky robot. That was designed by Stanford University research team. The ELIZA chatbot was by MIT. Then we come to this guy, Vladimir Vapnik, from Russia, from Soviet Union. He started to invent support vector machine. Support vector machine, he didn't create it overnight because it was a cold weather in Moscow, -30. No, he worked with support vector machine for almost 3 decades. But we didn't have at that time supercomputers. So he was in Soviet Union, and he sent 3 papers about support vector machine. It was rejected. He had a bitter feeling about it. Then there was a lady, beautiful lady from the US, at AT&T Bell's company. She wanted to work with character recognition, contacted this man. He was young, very young at that time. And she took him over to the US. And he worked in the same company, and they managed to solve character recognition by support vector machine, maximize the margin of the street. Then in 1997, there was also long-term short memory. That's recurrent neural network. That's, again, kind of machine learning. For me, 20 years ago, I said that machine learning is the magic. If there's no magic in our life, then machine learning is magic, whether you like it or not. This one, I said it 20 years ago. My colleague was doing a postdoc at UCD, and he moved to Austria to work with Schmieder, the inventor of support vector machine. Now then, deep learning, the true magic, came by AlexNet, a lot of layers, deep layers to extract features. And he worked with Jeff Hinton, another father for AI. Then came generative adversarial net. That was 2 networks, one for generator, the other one for discriminator. You fake the data, images, text, and then the second network, the discriminator, will find it whether it's a true data or not. That was also done in 2014 by Ian Follow, something like that. I will try to get his name. Then residual network by K-Ming came. That's, again, a network, but you skip some layers. You add input to the output. In some layers, you skip it. Then we have the time frame. This one, very beautiful. See, from 1940 to 1960, that was the foundation of AI. I mean, AI was there 3,000 years ago by Greek people. They found it to patrol the island of Crete. But then in 1943, the first artificial neural network was found. Then Turing test, Alan Turing. Then birth of AI, the conference. And then perceptron, 1957, the first single layer. Very simple, doesn't do much. Then Adeline, adaptive linear neuron. That's a neural network that can do training. Then we will have the first golden age, because the neural network, we have a neural network that does classification, at least plus and minus. But then in 1960 till 1917, there was XOR problem. You know, they know the gates, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0. That problem cannot be solved by simple layer. So, because they couldn't solve this problem, so we call it dark age or winter age, There is no advancement. We are stagnating at our place in AI. So, that one, the problem, the red one. And then there was a neurocognitron in 1980, the definition of convolutional neural network. Convolutional neural network, the base of the convolutional neural was in 1918, but then back propagation came with Jeff Hinton, the true magic to train neural network. And then we come to SVM. SVM stopped there. We couldn't do anything. The same AI, there is no advancement. Anytime no advancement means that dark age. Why dark age? Because SVM cannot solve deep learning. It doesn't have a deep learning. Then CNN came by Lucan, a French guy. Convolutional network, you could have 700 layers. And then you would have restricted voltage machinery. That's again for Jeff Hinton, the father. Until 2012, that's AlexNet, dropout, and GPU came. So two components that made AI very advanced. One, the data set, availability of data. The second one, GPU, graphical processing unit. And then the transformer came, the magic came. All this, it's a weak AI. We are in the weak AI right now. That's weak AI. Why? Because you tell the chat, does something. There's no empathy, there's no love, there's no anything, and only one task can do at a time. Now, there is another type of AI called strong AI. Strong AI means that we have a machine exactly behaves as human. Are we yet there? No. We don't have a machine can do similar functions of a human. So this one can be done by 2043, strong AI, estimated to be done by 2043. Now, there is, after this one, there is called super AI. You know, AI can do the behavior more than human, kind of God. That's in 2073, should be there. If not, then we are in the dark age. If we are in the chat GPT for another 10, 20 years, then we will be in the dark age. I hope that I explained this one. So that was the detail of it. The dark age, the second golden age, and then the dark age. Every 20 minutes, there is no advancement. It's a dark age in AI. Now, come to our topic, rethinking education.
With
in our
timetable
lab,
system,
we designed some software. This is a time scheduling
Here we can
for
choose
UK Edge
how many days
by
a
AI.
week we want the schedule to cover, whether 4, 5, or more, and from which day to which day. For example, Saturday to Thursday or Monday to Friday. Next, we manage our lecturers. We can easily add or remove lecturers, set their availability, and define their preferences, such as subjects they prefer to teach or times they are available. Then we add our courses or modules, including full details, such as the lecturer in charge, the year of study, UG1, UG2, and so on, and the specific program, for example, computer science. After that, we move to the classes themselves. Each module's lectures can be scheduled with precise rules, assigning them to specific times of the day, preferred rooms, or even morning or evening slots as needed. Finally, with just one click, we generate the full timetable. The schedule is displayed clearly and can be downloaded as both an HTML file or an Excel sheet.
This has more than 100 features, so there's no clashes. Nobody can complain. AI optimized it with AI algorithms. Now, if we skip this one, some task on Kurdish language, which myself and my student, Dr. Hawraz, now he's my colleague, did it for Kurdish language, text to speech. He sold it for 3 dafters to Rudao. But I didn't get anything from him. Sounding. There should be sounding. Text to speech. There should be speech for it.
ئەمە لەم کۆنفرانسا بەشداریمان کردووە. دووبارە بەخێبێن سەرسەران.
Now, the next one, speech to text. Again, same work, but different.
کنفرانسێک بەشداری دەکەین.
Be sounding. Now, the next one, we are taking OCR. You know, OCR, yeah. You have a text, you take it from image, and you convert it to text.
دێنە پلاتفۆرمەکە سەلێکتی ڕسمەکە دەکەین ئەبرنەوە پارچەمان وەرگرتووە ئینجا دێن ئۆسیاری بۆ دەکەین ئیسرائیل ئازادکردنی گیرا فەڵەستینەکان دوا خست و دەڵێ
I'm not responsible for the content.
تا کۆتایی.
Okay. And then this
Got it. So the lecture note is uploaded,
Teaching
then
assistant,
you type your
AI
instructions in the box
chatbot.
and click generate. After that, the AI teaching assistant creates questions based on your instructions, and you can customize them in the follow-up box. You can add more questions or change the type of questions. If you are not satisfied with a question, you can easily modify it. The AI teaching assistant makes quiz creation fast, flexible, and tailored to your class.
This was designed by Daniel, is my PG student. Then we have a summarization. If you have a PDF file and you want a book, 500 pages, then you want to summarize it in Kurdish language, which we don't have. And that's for how you summarize a text to tell you what's this about: sport, education, science, health. That's summarization. Okay? It's about masters and PhD in India.
Zingle
This
is
is
a
a
language puzzle game designed to preserve and teach
game
the Kurdish
in our
language.
game lab
Through
to preserve
text-based
Kurdish
and
culture,
grammar-driven
to
challenges,
preserve
players
Haurani,
interact with real
Gerdi,
Kurdish words and
Sorani,
phrases. The game
Zazai
blends simple
dialect.
storytelling
With the games,
linguistic
kids
puzzles,
play games, but
offering
they'll
an
learn
engaging way
Kurdish
to
language.
explore and support endangered languages through interactive play. With a minimal and stylized look, Zingle focuses attention on language itself, encouraging players to think critically about meaning and structure.
Yeah. So here, what made AI
I
very
introduce
advanced?
to you Leonardo. and he's going to paint a picture.
The difference
for you
between
guys
CPU and
in the way
GPU.
that a CPU
Without
might do it,
GPU,
as a
AI
series
couldn't
of
make this
discrete actions performed sequentially, one after the
big
other.
leap.
In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
One click. And that's because of GPU.
Ladies and
Now,
gentlemen, science class is now over.
so you see the difference between CPU can do 3 multiplied by 5, 15, many tasks, but simple tasks. GPU can do in array and vector. Now, he brought all these materials, but I can make it simpler in my explanation. I can explain it this way. That's CPU, central processing unit. A chef can do 1 egg, can fry 1 egg or cook 1 egg. GPU can do array of eggs at the same time, parallel. Same task, but in array, 5, 10, 20 eggs. TPU, which he didn't explain it, TPU, tensor processing unit. Yes, thank you. This is assembly, a machine that brings egg all the time. So that's, I think this is easier to understand it, my one. Anybody goes for this one? So TensorFlow, GPU, CPU. This is the advancement of AI. Now we come to, before AI, things were limited. You know, people were scared, you know, hesitant, whether they go for AI, they adopt to AI. AI was only for some tech companies, gigantic companies. Say, for example, Microsoft, Google, big companies. And top-ranking institutions. Not every institution can use AI at that time. You don't have license. You wouldn't get free access or free sources. And students also, they didn't have that access. Because mainly this is for research, before AI. Before 2017, before the paper, Attention All You Need, from the Google Mind. And then teacher was hesitant. They didn't believe in AI. Now, after that, you know, like AI became mass adoption, personal tutors, you know, people all use AI. Not only in education, every user, they use AI. Everybody uses AI. Teacher's assistant, like I showed the program, at least, that we did it. And then the tools are free. You can download them anytime. You know, they are free. Anybody can access AI. Here we have to spend some money on AI. See, this is the rapid rise of AI in education. I have 6 minutes. I have to finish it quickly. So teachers, 60% of teachers, they adopt to AI. They try to change their stuff to AI. Only 39% they're not sure. Then 3% not sure, and then 1.2% they do not go for anything. They're drifted. They don't know what to do. We talk about some economics, global AI in education market. This is done by Forbes research team. You can see in 2020, the growth in AI, spending money, pouring money into AI was 2.5 billion. In 2025, this year, became 6 billion. So now they were kind of hesitant, but then in 2032, everything is AI now. How much they spent? 88 point something billion. So we need to spend some money on AI, okay? Now, the countries that they are paying more attention to AI, it is North America, 38%. But then second comes Europe, 30%, 29%. And then Asia, Korea, Japan, China, they come with the 23rd place. And then Middle East and Iraq and those countries, 3%. Latin America, I forgot, 7%. So still America spends a lot of money on it, and that's how they control the world. What we have to do, our role, we have to change our style from grader or evaluator or assessor to role model, to guiding, to mentor, to coach, to check, to critical thinking about the students' output. That's our role. Also to follow the policy, AI ethics. Now 4 minutes I have. Now we need to educate our students with the AI ethics. A lot of problem right now because technology is going very, very fast. But then lawmakers or policymakers are very slow. We need to work with ethicals. We need to have our own ethical regulation. Now, we teach our students to be careful with bias, with reliability, ethics, things like that. That's how we can change ourselves. And critical thinking, not just use the AI, but then once you used it, what's the output? How you think about this output critically. That's important. And also, as I said, that we all know we are going to use AI, but how to use AI, we can give AI a prompt. Prompt could be vague. For example, tell me about environment. You're making him crazy. He cannot understand, so you have to have a structured prompt, okay? A bit better prompt. If you are working at civil engineering or architectural engineering or science or health, you should be a prompt engineer in the future. More or less about balancing ethics. For example, if you want to create a machine, a robot, to take the role of psychotherapy, okay, to treat a patient or a student. Student might have some feeling, bad feeling about someone, and he tries to kill him. So if this machine talks to the person and tries to take information, that's part of his duty, then student will talk to the machine and says that I'm going to kill X person. So ethically wrong, because he should not take this information, or he should take information, but he should not allow the, what you call, he shouldn't tell the authorities that this person will kill that X person. So there is a lot of ethical issues there, and we don't have time. We can talk about ethics all day, all night. Now, we have to work with AI. I encourage everybody to work with AI and be prompt engineer, work in ethics. I think I'm done, if you have any questions.